All right, today we are looking at arithmetic sequences and partial sums. So your arithmetic sequences are your sequences where you are adding the same number every single time or subtracting. So the difference between each term is the same. So looking at these sequences, which you should have completed from yesterday's notes, decide which ones are arithmetic. When you look through these, the first one, the fourth one, and the fifth ones are the only ones that have to do with adding and subtracting. But on the fourth and fifth ones, you're not adding and subtracting the same amount each time. Whereas on the first one, you add 4 every single time. So this one is called arithmetic. And your common difference, what we'll refer to as D, is 4, because that's how much you're adding each time. If you were subtracting, it would be a negative number. Alright, so find the next 4 terms in the arithmetic sequence for each of these. When you're doing that, first identify how much you're adding or subtracting. So from here to here, I do plus 3. Here to here, it's plus 3. So my common difference is 3, and I can keep doing that to get the next 4 terms. Go ahead and finish this one and do the next one on your own. First one, your common difference was 3, so I continued to add 3. The second one, your common difference was negative 7, so I continued to subtract 7 each time. When you are dealing with arithmetic sequences, you have this explicit formula that you can follow. What you need to pay attention to is a sub 1 is your first term. Sometimes we will use a sub 0 because it's a much more straightforward formula, but that means you would have to work backwards from your sequence to find a sub 0. So if you want to go with what's actually given to you, it's best to use the second one. So write an explicit formula for a sequence whose common difference is 3 and whose first term is 2. So I plug those in, leave everything else the same. That right there could be my explicit formula. Looking straight at that, I can see that my common difference is 3 and my first term is going to be 2. You could distribute that, so 2 plus 3n minus 3, which would actually be 3n minus 1. That would also work for your explicit formula. And actually, if you had gone up here, plugged your 3 here, gone backwards to your 0 term, so if I start at 2, and so I'm going backwards, I would subtract 3. So go backwards and subtract 3. I get negative 1. So I get negative 1 plus 3n, or 3n minus 1. Same thing. With recursive formulas, it's where you're using the previous term within your formula. And you have to have both pieces, because you have to tell me where to start, and then you have to tell me what you're adding. So for this one, a sub 1 is equal to 11. And then when I look at this, from 11 to negative 1, I subtract 12. Negative 1 to negative 13 is minus 12. Again, minus 12. So a sub n equals the previous term minus 12, or plus negative 12. So just as an example, if I wanted to find a sub 5, I would use the previous term, which would be the fourth term, minus 12. So that would be negative 37. This is just another way to write them. You will be asked to do it this way. Make sure your recursive formula, again, includes 2 pieces like that. All right, when you're writing your terms of your arithmetic sequence, you still want to look back to those formulas. So if you need to look back, make sure you know those formulas. So just to kind of help here, I'm going to go ahead and write down my formula for my explicit formula for my arithmetic sequence. So the fourth term of an arithmetic sequence is 20. So I need to write down what I know. A sub 4 is 20. The 13th term is 65. Write the first several terms of this sequence. I need to figure out what my common difference is. So I'm going from 65 to 20. So I want to figure out how much I'm changing, how much my values are changing within, 9 different terms, going from 4 to 13. And that was just 13 minus 4. So 65 minus 20 is 45. So my values have changed by 45 while I've gone up 9 terms, which means that each time I'm going up by 5. So my common difference is 5. So to find my first several terms, let's say, I'm going to have to go up here. 20 was my 4th term. To go backwards, I would subtract 5, subtract 5, subtract 5. This would be 1st, 2nd, 3rd, 4th term. I could go to 5th term. That should be good for my first several terms. If you wanted to write your formula, you'd have a sub n equals 5 plus n minus 1 times 5. And you could simplify that. I'm going to leave it like that for right now just so that you can see first term difference. But you could simplify it, and that would be 100% okay and probably preferred. Go ahead and try to do the second one down here. When you do this, you want to actually use this formula up here. You don't want to write out just the first 7 terms, because if I had asked for the 100th term, you wouldn't write out 100 terms. So I know my first term, I know my second term, which means I know my common difference to be 7. So if I'm going to write out my explicit formula, it's a sub n equals the first term, which is 2, plus n minus 1 times the common difference, which is 7. From there, if I want to know my 7th term, all I have to do is plug in the 7. Again, you could have simplified this right here. It does not matter since you're just using it. It's not a final answer anyways. So 7 minus 1 is 6. 6 times 7 is 42, plus 2 is 44. That means the 7th term of this sequence is 44. All right, the next thing we're looking at is our sum, or our series. So the sum of the first n terms. So if I wanted the sum of the first 5 terms of an arithmetic sequence, then we use s, and this would be a 5. And I would do 5 divided by 2, and I'd multiply that by whatever the first term is and whatever the 5th term was. So if I want the sum of the first 60 terms, then s sub 60 equals 60 over 2 times first term plus 60th term. And since they have this dot, 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 and then the 304, I know from that this is my 60th term. So 9 plus 304, and then times 30 is 9,390. So if I added the first 60 terms, this would be my answer. Find the sum of the first 32 terms in this arithmetic sequence. Okay, so this time they don't give me the 32nd term, so I need to find that. So I'm going to start by writing my formula. My first term is negative 12 plus n minus 1 times, and I got to look at my common difference, which each time they are adding 6, so times 6. There's my explicit formula. It wants the first 32 terms, so I need the 32nd term. 32 minus 1, I'm just going to write 31. Don't lose your plus sign like I just did. 31 times 6, excuse me, and then plus a negative 12 would be 174. That's the 32nd term. Now I can find the sum of the first 32 terms. 32 divided by 2 times, and then my first term plus my 32nd term. So I'd add those two, multiply it by 16. Which should be 2,592. I want you to try this third one on your own. When it says the 150th partial sum, that's the same thing, because this could be an infinite series that just goes on forever and ever and ever and ever and ever. I just want the first part of it, the first 150 terms. I had to write mine on the top because I didn't have enough space here, but I started by getting my formula for this sequence, found the 150th term, and then I was able to plug that into my formula for the sum. And I ended up with 123,675.